All right, this is Algebra 1B Part 2. This is Unit 1, Lesson 8. We're nearing the end of the first unit. The concept is being able to tell the difference between linear, quadratic, and exponential models. Linear, quadratic, and exponential models. So I've got on the screen here 3 graphs, 3 tables. As you might imagine, the one on the left is linear, the one in the middle is quadratic, and the one on the right is exponential. And we're going to explore the differences between them. Linear, quadratic, and exponential. Okay, all right. Now I notice I'm not giving the formulas. We're telling the difference by the graphs and by the tables. All right. So let's graph them here. Let's graph the linear model here. So 0, 5. 1, 7, 2, 9, 3, 11. Okay, and I'm going to go ahead and draw a line through those dots. The hallmark of a linear function is that it is linear. It is linear, right? It is in the shape of a straight line. Okay, by straight we mean not curved, not horizontal or vertical, but not curved. It's a straight line. It may be diagonal. It probably will be diagonal, but it is straight. It is not curved. So it is linear. Okay. The quadratic we've already explored in this unit because that's what this unit is predominantly about. It forms a shape called a parabola. Let's take a look at this. 0, 1, 1, 2, 2, 5, and 3, 10. And we get this kind of half U-shaped going up. Okay. Now if we were to map the rest of it, it would be mirrored right here. Right here. Okay, and we would graph the second half over here, but the second half is not given in the table. That shape is a parabola. Okay, that shape is a parabola. Now it can be a little tricky to tell the difference between a quadratic and an exponential, especially when only one half of the quadratic parabola is given. But we're going to explore how to tell the difference here. So this last one is exponential. 0, 1, 1, 2. Notice those are the same points, 0, 1, 1, 2, as in the previous, but now it goes off here a little bit. 2, 4, 3, 8. Okay, it goes out a little flatter, right? And if I were to graph the left half of it, actually what it would do here, is go down like this. It's kind of a ski jump shape, right? If we graph the exponential. So if you have the whole shape, the whole graph, you can tell the difference because U shape is quadratic and ski jump shape is exponential. But again, if you're only given the right half, it's hard to tell the difference, right? So here's one way to tell the difference. Look at the differences. If the x's go up in a constant fashion, 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3, examine the first differences between the y's. From 5 to 7 is up 2. From 7 to 9 is up 2. From 9 to 11 is up 2. Okay. So notice for linear, the difference is constant. That's common or constant difference. Right? The first difference is constant. Right? They're all 2. Look at the first differences on the quadratic. From 1 to 2 is up 1. From 2 to 5 is up 3. From 5 to 10 is up 6. Up 5. Okay? So the first differences don't tell us much, but now let's look at the differences between that we call them the second differences. From 1 to 3 is up 2. From 3 to 5 is up 2. So a quadratic has a constant second difference. Constant second difference. Okay? Quadratic has a constant second difference. Right? And look at the exponential. You're not going to get the same pattern here. From 1 to 2 is 1. From 2 to 4 is 2. From 4 to 8 is 4. From 1 to 2 is 1. From 2 to 4 is 2, right? And so the second differences don't have any common factor. But let's look at what actually is happening. What actually is happening is we've got a constant multiplier. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. Okay? So the way to tell an exponential function is we have a constant multiplier. Constant multiplier, we call it a constant ratio, because the ratio between terms is constant. Okay? So that's really the way to tell. Now, if you want a formula, the formulas are as follows here. The formula for the first expression is y equals 2x plus 5. The formula for the second was y equals x squared plus 1. And the formula for the next one is y equals 2 to the x. 2 to the power of 0 is 1, 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8, and so forth. So those are the formulas. That's linear, quadratic, and exponential. All right, hopefully that helps. You'll get more information in the lesson itself.